Another counting rule is a combination, and the combination, what's special about that is that it's a selection of objects without regard to order. Think about more of a choosing a group. It doesn't matter if you're the first member chosen. If there's a group of 5 people. It just really doesn't matter the order. So if we look at this example, it says given the letters A, B, C, and D, list the permutations and the combinations. So if we go with first permutations, we can have A and B, we can have A and C, or we can have A and D. Or we can have B and A, B and C, B and D. Because this case, A, B, and B, A, yes, they're the same letters, but in a permutation, order matters. A, B is not the same as B, A. If A comes first and B comes second, that is not the same as B coming first and A coming second. So that's why we list them both. CA, CB, CD, and then DA, DB, and DC. So we can see here that we have 12 different permutations. If, however, though we want to work with a combination, order doesn't matter. So we can actually take the same list right here, but take out the repeats now. AB in a combination is the same thing as BA. AC, same as CA. AD, same as DA. BC and CB. BD and DB. CD and DC. So in this case, combination, there are only 6 possible combinations because the ones that are repeated basically are the same thing. We have our combination rule, like we had our permutation rule, and we denote it as the number of objects selected from n total objects. And you're going to see it looks really similar to permutation, except we got to divide out those repeats, and that's what this extra r factorial means. So if we look at an example, how many combinations of 4 objects are there taken 2 at a time? Well, remember our formula is n total objects taken r at a time, and that's n factorial over the difference factorial and then r factorial again. So in this case, we have 4 objects taken 2 at a time without regard to order. So I'm going to go 4 factorial over 4 minus 2 factorial times 2 factorial. Probably can just use the button on your calculator, but just so we have an understanding of what's going on here. Remember, this means 4 times 3 times 2 times 1. Let me just simplify it before I guess we get there. 4 minus 2 is just 2 factorial times 2 factorial. This, again, though, means 4 times 3 times 2. Instead of saying times 1, I'm going to leave it as 2 factorial. And then down here, I'm going to go 2 times 1 times 2 factorial. And the reason I do that is because then we can cancel these out. And I'm left with 4 times 3, which is 12, over 2 times 1, which is 2, and we end up with 6. So how many combinations are there of 4 objects taken 2 at a time? There's 6 combinations. Remember I said the combination formula looks really similar to a permutation. In fact, if we remember here, permutation of n objects taken r at a time is n factorial over n minus r. And that's kind of this part right here. So what we can say, and you just, as you might see this, is you can take the permutation, divide it by r factorial. Basically, take your permutation and then divide out all the repeats. Looking at an example here, it says a newspaper editor has 8 books to review. He decides that he can use 3 reviews in his newspaper. How many different ways can these 3 reviews be selected? Now, order doesn't matter. If you have review A, B, and C, that's the same thing as review B, A, C. There's not an order. Something doesn't have to come first. So it's going to be a combination, and we have 8 objects taken 3 at a time. So So we're going to go 8 factorial, our formula, 8 minus 3 factorial times 3 factorial, our standard combination formula. And if I want to simplify this, I'm going to say that this is 8 times 7 times 6 times 5 factorial, and the reason I'm leaving that is because 8 minus 3 is 5, and I'm going to be able to cancel those out. So those cancel. I'm left with 8 times 7 times 6 over 3 times 2 times 1, and that equals 56. So there are 56 different ways these reviews can be selected. One more example. In this case, there's 7 women and 5 men in a club. Now you're going to have a committee that consists of 3 women and 2 men. How many different possibilities are there? We're actually doing 2 things here. We're taking a committee, and this is a combination because you think of a group of people, it doesn't matter what order you're in. And we're going to take 7 women and choose 3 of them. But we're also going to take 5 men and choose 2 of them to be on this committee. Think of our fundamental counting rule, and we can say the number of events, you just multiply them. So the number of different ways we can pick women times the number of different ways we can pick men. If you take 7 combination of 3 and do the formula out, or just type 7, use the combination button in your calculator, 3, that works out to be 35. If you do the same thing for the men here, there's actually 10 different ways. So using our fundamental counting rule, multiplying together, if we have 35 different ways this event can happen, choosing a woman, and 10 different ways this event can happen, choosing a man, we just multiply them together. So in a club of 7 women and 5 men, if you are creating a committee of 3 women and 2 men, there's actually 350 different possibilities for that committee. Well, for it to be, or who it's made up of, excuse me. So there's a lot of different possibilities, which you really wouldn't think when dealing with just 7 women and 5 men. Permutation and combinations. The thing to remember is in permutation, order matters, but in combination, it doesn't.